pairs of congruent sides.
And how do you know that a rhombus cannot be a kite? And I want you to refer to the definitions because that's a really important part of math. So look at the definitions.
And this side is not parallel to this side.
Okay, all sides of what have to be parallel?
All sides of a rhombus have to be parallel.
Are you saying they're all parallel?
Or no, like the opposite sides are parallel.
Okay, all right.
And then of a kite.
What does it say about the kite, Chris?
Opposite sides are not parallel.
Ah, opposite sides are not parallel. So there we go. Now what do we know from that?
But they're not.
That
They cannot.
What's the they? Be careful, those pronouns.
Rhombus and the kite.
Are not, or a rhombus is not a special kind of
Rhombus
kite.
is not a special kind of kite. Okay, good. All right, you're doing great. So do you have a plan to move forward now? How are you doing?
Well, we still have to figure out we're still trying to find out how we can do a trapezoid, a regular trapezoid.
Okay, so here's what I don't want you to get derailed on that because that is hard. So let's do this. Let's do all the other ones first, including an isosceles trapezoid, but don't worry about the not isosceles trapezoid for a while. And if you're ahead, then you can try to work on that one. Okay?
We split up the shapes between us each, which ones we understand most, and then we shared how we found it with each other.
You did?
Yeah, like the requirements that it needs to have to make the shape.
To make the shape every time.
Wow. And so are you knowing all the
Well, we're trying to figure out how to make a right angle trapezoid.
Because we found out how to make a trapezoid, but then we need to make there's different trapezoids to make each time.
Okay. So when you're talking about you found out how to make a trapezoid, what kind of trapezoid were you talking about?
We made a regular trapezoid.
She was the one who found out how to make a trapezoid.
This. Okay. What kind of trapezoid is this? It's regular. What's the word? Is there
No.
Okay.
Convex.
What's special about this trapezoid?
These two sides are congruent.
Okay, that's called an isosceles trapezoid then. And so here's what I'm going to suggest. If you're sure that you can guarantee an isosceles trapezoid, don't worry about the not isosceles trapezoid till you get all done with everything else, because that's really that's a problem all in itself. All right. So now let's see. Have you? I guess where are you in this investigative process?
We're aha proving kind of.
So do you have your ahas for every single shape?
That's what we're doing.
Okay.
We're writing down.
Excellent, Jerry. And so then the next stage would be to go on to the proving, explaining part. And you're actually making so much faster progress than I thought that I haven't even talked about what to do with that. But you're doing. This looks really good. Do you feel good about the work you're doing so far?
So then wait. So I just doing this out of curiosity. So this is just because they're both congruent. Well, I said opposite sides are parallel, and then diagonals cross at same spot or length. So if they sides, so you made this at same spot and same length. What if they're different length? You think it'll make a different trapezoid? I think it'll make it a trapezoid with.
No, when I said same length, I meant at these two.
The same hole.
Oh, at the same hole.
Yeah, or
Say it's
these
same.
two.
So if it was that, would it be a different
That wouldn't be a trapezoid.
What about how would you then? This is bugging me. How would you make it a trapezoid that's not isosceles then? If these are both congruent every time.
I don't know.
Wait, these are wait. All they have to do is just two parallel sides, right?
Yeah. Well,
So what if you make it? What if you make it like this though? Wait.
None of the
That's what
sides
I
are
thought it
parallel.
What if you make it like this and it's just is that no?
No, but that isn't parallel to the other one.
Maybe it could be like this.
No, that's not parallel.
These two are parallel, right? Ow.
Whoa, yeah, those two might be parallel. And then is that? But then
Where's another
pen right here.
no piece of paper?
Right, don't we ran
Take a
out?
piece of paper.
I'll get some
we
more.
have a pile?
Yeah, I'll get some more.
Because don't these look parallel?
No, that one looks like.
Or maybe if it was like this.
They laid on the table.
Oh, that's the same thing.
Yeah.
They're not perpendicular. Push it up a bit because it's off. Oh, that's good. That's good. That's it.
Wait.
Are we doing proving and explaining? Is that what we're doing right now?
Which sides are you trying to make parallel? These? Which ones? Let's just try it. I don't think we have to prove this, but it's just bugging me. Okay. How do we test it with the compass? You want to test it with the compass to see if it works?
Or like we can measure different points, like from here to there and then from here to there. You know?
Wait 1 sec. This kind of looks like a trapezoid, doesn't it? Oh, that's not parallel. That's not parallel. Nope. These sides are not parallel. So this is not a trapezoid.
That's a
Trapezium. So yeah, so I don't think we even need to prove that. She told us we don't. She told us it's a problem within itself. So
we made a trapezium.
we made a trapezium, yeah. Trapezium.
Still want to find out how to do like a right angle.
Trapezoid, me too. How about this? How about we prove we all write down each one, like I got square rectangle, I got rhombus, and then now I'm gonna do parallelogram, then I got to do kite and trapezoid. And after that, we'll try to find a right angle trapezoid. Okay? But first make sure you have every single one.
I don't have rhombus.
Here, I have rhombus right there.
Only one side of the intersection must be congruent. So this is the not a midpoint, but a point that segments this segment. And only this part and this part must be congruent. So then on the other side, these are parallel. The sides are they're created. These. Okay,
Okay, stop for just a second. Dorothy, you're in a really good place. You were at an aha and you had that flash of insight and then it kind of vanished, right? That's okay. That's good. So why don't you try to talk yourselves through it, or talk yourself through it, or you can all try to fiddle around with Dorothy's idea. But so there's something about where you put those two together and what angle they're at, because you're trying to create.
I think I got it again.
Okay, you talk to your group about it then. I have complete confidence in you.
Okay. Because these aren't congruent. So just pretend that they are. Then we'd have to cut some of the blue one off because the sticks need not be congruent. And I don't want to do that. So pretend that these are congruent. This is congruent, but the side and the side are not congruent. These are parallel. Even though they don't look parallel because
he tried it like that and he didn't get one.
No, wait, so that means this triangle over here has to be perpendicular.
Yeah, he made one like that, two different lines.
But is this perpendicular? Yes, right? No?
no, it doesn't need to be perpendicular.
No, once it's
necessarily.
perpendicular, then these two lines can be parallel. You see, because if this is not perpendicular, then it's not.
But shave off this. It's not. This side isn't congruent to that side anymore.
No, I'm saying the diagonals have to be congruent. Right? Or,
This that's required to make vertical angles, right?
okay, wait, let's draw this out and see if it works.
Oh wait, no.
That's one way.
No. You guys swear?
Well, trapezium.